Hello, everyone. Welcome. We are so glad you could make here in person today. I'm Vidhi Taneja, and I'm a Principal Product Manager here at AWS for Amazon Managed Streaming for Apache Kafka. I have with me Farooq Omer, who leads the data engineering team at Sony Orchard. In our session today, we'll talk about how many of our customers have been able to innovate faster, like Sony, and the time taken to build new products and services from weeks to days, while making real-time data accessible throughout the organization, leveraging Amazon MSK. We'll start with talking about some of the business opportunities you can unlock with real-time data. We can then delve deeper into Amazon MSK, what it can do for you, how it can help you eliminate some of the operational burdens and reduce costs while making data accessible throughout the organization. I'll then hand it over to Farooq, who'll share their experience of using Amazon MSK in Sony, and then some of the lessons learned. We hope by end of the session, you'll be able to take these lessons and apply them in your organization. So let's get started. Now, data, as we know, is fundamentally changing how we live our lives and how we operate our businesses. As per a report published by Forrester, data has a very short shelf life. And what that really means is that sooner you're able to analyze this data while it is being generated, sooner you can harness the value, more valuable it can be for you and your organization. 58% of the organizations that were surveyed told that they were able to achieve better customer retention and loyalty by leveraging customer analytics. With access to real-time data, you can take timely and accurate business decisions. You can uncover new business opportunities and make intelligent products and services that are customized and cater to your organization as well as your customers. So, real-time already has quite a few use cases. For example, when you shop online, apps and websites are already monitoring your behavior. They're looking at your clickstream data to recommend you products that you're more likely to purchase while you're making your product purchasing decisions. Banks are using real-time data to detect and protect you from fraudulent activities. IoT devices are continuously generating and sending this data to be analyzed as well as acted upon to cater to the unexpected situations. And data streaming platforms are at the core of making these use cases possible. Apache Kafka, as you may know, is one of the most popular data streaming platforms. It is an open source, distributed, even streaming platform, I'm sorry about my voice, that is trusted by over 80% of Fortune 100 companies. Apache Kafka can ingest data at extremely high throughputs and low latency and make them available for the downstream consumer applications in the order the data is generated. It's highly durable and fault tolerant. And what that means is that it automatically copies the data to the disk. It persists the data to the disks, and it also replicates across the cluster to multiple brokers within the cluster. And with its rich ecosystem of tools and connectors, you can build innovative applications, real-time applications, leveraging Kafka. So now while you can create your own and build your own Kafka environment, what we are hearing from customers is that it can be quite challenging. It is tedious and time-consuming to build Kafka deployments that are highly available and can scale. It hampers business agility, growth, as well as the long-term success for the organization. Now, multiple teams within an organization need access to real-time data, and not having a Kafka expertise within these organizations is a challenge, and that slows them down, hampers innovation within these teams. Operating Kafka at scale and high availability is not an easy task, and it's often expensive. Your developers are spending their valuable time just operating and managing the infrastructure, keeping the lights on, rather than focusing on building applications and products that help your business as well as your customers. So in order to address these challenges for these organizations, we launched Amazon MSK as a fully managed solution for Apache Kafka and Kafka Connect. Amazon MSK does all the heavy lifting of creating and managing Kafka environments for you. It provisions brokers. It orchestrates any patching or upgrades. And then it automatically replaces any components that fail so that you have the cluster that is with high availability. And throughout this process, it also applies best practices, design principles, and automation based on our learnings from tens and thousands of customers using Amazon MSK at scale. By leveraging MSK, you get time back, your developers get time back so they can focus on building applications that move the business forward and are customized and catered to your customers. So now let's look at MSK in further detail. MSK is fully compatible with open source Apache Kafka. So if you have your own Kafka deployments, you can just lift and shift those deployments over to MSK and be assured you'll get same or better performance when running Kafka in MSK. And during this process, you don't have to make any changes to your code. So it's a pure lift and shift to MSK. Now, the performance, as I mentioned, like it's same or better than running Kafka on your own on MSK, and we are doing a lot of improvisations on top of Kafka when we are running Kafka as part of MSK. We make newer versions of Kafka available within 7 days of public availability, which means you can choose to upgrade your clusters and be at the latest versions of your deployments of Kafka. And when you're doing these upgrades, we follow rolling upgrade process, meaning that the upgrades happen in place one by one, and there's no impact to the availability of your clusters. Now, MSK clusters are also highly available. When we create these clusters, we deploy them across multiple AZs. You can pick whether you want 2 or 3 AZs. So you get AZ protection by default by running MSK. The data is replicated across these different brokers that sit in these different AZs. And the best part is that you don't have to pay for any data replication costs on brokers across these different AZs. If MSK detects unhealthy clusters, it automatically replaces them, the components for you. So be it Zookeeper node, be it broker, be it storage, we will automatically replace those failed components so your cluster is up and running and healthy at utmost times. You can scale MSK clusters as you like. You can scale horizontally by adding more brokers to your cluster, or you can scale vertically by changing the family or instance type or different sizes within the family. MSK is designed for high security. You get multiple levels of security. Data is encrypted at rest as well as in transit. You get VPC isolation. You can leverage IAM roles and policies for granular access control. And you can use SASL SCRAM or TLS-based authentication for your clients. MSK clusters, like application development with MSK, is quite simple. And that is because we have done the hard work of integrating MSK with various AWS services. For instance, MSK natively integrates with AWS IoT as a data source for event streaming into MSK. MSK can act as an event source for AWS Lambda. You can use Glue Schema Registry for governance of your streaming data. Or you can also leverage Kinesis Data Analytics, which is managed Flink for streaming processing. And as it was announced yesterday, with Redshift streaming ingestion with MSK, you can create materialized views directly on top of your streaming data. Now, thousands of customers have been using MSK for building their real-time applications as well as a reliable backbone for their mission-critical applications. But we also hear from our customers that they have additional use cases wherein they may want to have longer retention time for their messages, but at a lower cost. So here at AWS, we listen to our customers and we innovate on behalf of them so they can meet their business goals. I'm happy to talk about tiered storage feature that we launched as of last month. Tiered storage provides you a cost-effective tier that scales to virtually unlimited storage without a need for you to provision or manage storage. With tiered storage, you can retain data for shorter duration in performance-optimized tier, or you can use this feature for retaining messages in a cost-optimized tier, wherein with tier storage, it automatically copies data over to cost-optimized tier. You can also increase your Kafka topics storage without a need to add additional brokers to the cluster. So with tiered storage, you can scale your compute as well as storage independent of each other. Now, when it comes to consuming MSK, we provide flexible options for you. You can use MSK provision, which gives you complete control of managing your clusters. You can create clusters with custom configurations, as well as scale your clusters, figure out what's the right size of cluster that you may need. So with provision, you're managing your clusters yourself. Then we have MSK serverless. With MSK serverless, we automatically provision the capacity for you. You don't have to worry about right-sizing your environment. You don't have to worry about how many brokers you may need. We do that for you. And we also automatically manage the partitions. You get throughput-based pricing, so you'll only pay for what you are using. And then we have MSK Connect. MSK Connect provides you a fully managed Kafka Connect environment. It automatically scales and helps you get data in and out of MSK. So since launching Amazon MSK in 2018, We've seen a tremendous growth of our customers leveraging MSK. We serve tens and thousands of customers each day for their streaming applications as well as the nervous system, so to say, for their mission-critical applications. And here are some of the customers who are using MSK at scale. So on behalf of our team, I'd like to take a moment to thank all of you for bestowing trust in MSK and building and running your business on AWS. So with that, I would like to invite Farooq on stage to discuss how MSK has helped them innovate, accelerate the innovation in their organization. Thank you.
Thank you, Vidi. Hey everyone, I'm Farooq. I am from the Orchard, and I'd like to say I appreciate you all being here. It means a lot, especially given you could literally be anywhere else. So thank you. Before I start things off, I want to tell you a little bit about what the Orchard does and what my role is at the Orchard. So the Orchard is a music services company, like its parent company, Sony Music. And what it does is help artists be able to deliver their music to their fans, whether they listen on Spotify, Apple Music, or any of the other hundreds of digital service providers, or physical stores in the form of vinyls, DVDs, CDs. Yes, people still listen to that. Cool. And my role is being a music fan, but also leading the data platform teams at the Orchard. Cool. So I'd like to kick things off with a bit of a cheesy quote. We're at reInvent, but it's also apt. You have to have the leadership will to invent and reinvent. It really sums up our culture towards engineering at the Orchard. We try and align our teams towards those business services that I mentioned earlier, delivering music, helping fans be able to collect royalties and paying artists, to publishing services. We try and staff our teams to be as cross-functional as they can be and have control of their whole stack. So we let them choose the best tool for the job, the best data store for the job. So going into our talk, innovation is a buzzword that people throw out there, and it's something that's really challenging to do. It's especially challenging if you have distributed cross-functional teams across the globe, when these different teams have the power to choose their tools and their data stores. And there's rapid dependency and data movement between these different products and teams, even more so when you're doing it at scale. The Orchard's market segment is the indie music segment. So that's the long tail of the music industry. Think about the band that plays at the bar around the corner from you every week, or your neighbor that's trying to make it in the industry. Cool. Now, as an artist, how do you interface with the Orchard? You use it to be able to compile content, an album that you're about to release, make sure it gets to Spotify, Apple Music, and so on, but also be able to collect royalties. So you're using a suite of products, and these products need to talk to each other. They need to understand each other, right? So in order to do that, you have these teams that are aligned towards providing services such as accounting and so on. So what do they do when they need information from the content team? They copy it over to their database. I'd do that if I was an engineer. Same thing for the analytics team. It needs to understand who's being paid, so it copies information from the accounting team. These three diagrams are just showing three different teams moving information across. And what you quickly end up with is a complex web of point-to-point connections. Every team is writing it in whatever language they prefer. It becomes quickly hard to then have something consistent that you can easily understand if there's a problem within your logic. It becomes hard to understand the source of truth. The analytics team copied some bit of information from the accounting team. The publishing team then decides to copy it from the analytics team, but they don't own that piece of information, right? That brings about confusion. That makes it hard to debug. It makes it challenging to scale. slows down your pace of innovation, and really slows down your whole team's velocity and productivity. So, how did we go about solving this? We set up a cross-functional horizontal team comprised of members from all those various different teams I mentioned in order to create a platform to enable system interoperability. Now, I'd like you guys to look at this diagram for a second. I want to imprint it in your minds. Throughout this session, we'll go about how we went around building a platform like this that enabled teams to gain back their velocity and innovate. Cool. So I will tell you the story that we went through, which is we wanted to start by providing real value. We wanted the first use case that this platform powered to be something that customers could see the impact of, to prove it. And then after that, I'll tell you a bit about the consequence that we realized off the back of that was enabling an event-driven architecture within our system and letting us get closer to that first slide that Vidi told us about, right? Being able to act quicker on events that happen within the system. And then thirdly, I will go over how we took MSK and looked to see how we could reduce toil around the organization and increase operational efficiency. All right, the first one, powering a better search experience. So this is a diagram of how one of our applications, the analytics app, used to service users. So the flow here is typically a user, let's assume Kanye West is about to release a new album. They use our album maker application, it gets created and it's stored in our music graph, our corpus of music information, right? So, cool. The analytics team, they usually work within Snowflake. So they get their streaming information from Spotify, Apple Music and put it into Snowflake, and they need to be able to match that content with music, right? So what they do is they copy that information from Neo4j into Snowflake, which takes about 10 hours to do, because remember, there's millions of music that exists in the world, hundreds of thousands of artists. Cool. So that's a 10-hour data lag for the user, right? You have to wait up to 10 hours to see the existence of some new piece of music. Couple that with the fact that you're doing search directly on a service that wasn't built for that. If you've used Neo4j or any kind of graph database, you know it's not good for text search. It won't understand when you have a typo, and it's resource intensive. Cool. So how do we go about addressing this? First and foremost, we realized the need for a search-specific service. So we decided to go with OpenSearch. OpenSearch is great. It's a text search database. It's meant for that. It's really good, and it's tried and tested. But in order to do that, we didn't want to put ourselves into the same hole of having to copy data from our knowledge graph into OpenSearch and it take 10 hours. Defeats the value, right? So what we did is we brought in MSK and used it as a sort of message bus to be able to connect our knowledge graph with OpenSearch in a real-time manner. And what really enables us to do that is by tapping into what we call Kafka connector. So Kafka Connect has an open ecosystem of configuration over code applications, as it were. You give it a configuration of where a data store is, you tell it a topic you want it to replicate to, and it will look at any changes that happen within that database and put it into the topic of your choice, or the reverse if you're trying to push to a data store. So we're reading directly changes that happen in our music graph, pushing that into a topic, and from that same topic, we're pushing it directly into OpenSearch using a Kafka connector. Cool. So now you have, in real time, any new music that appears, your clients can search it. But we realized there's another opportunity here. That script that took 10 hours to load from our knowledge graph into Snowflake, we could get rid of that, right? We have a stream. Any change that happens, we can just push that directly into Snowflake using, again, a Kafka connector for Snowflake. Cool. So now you've gotten rid of two things for the user. One, they can search better. Two, there's no data lag anymore. But there's another thing we realized we could do here. We could provide intelligent searching, intelligent scoring. And what do I mean by that? Let's say there's 100 Beyoncés in the world. I know there isn't, there's only one Queen Bee, but let's assume there's 100 of them. You want to search and, which one are you looking for, right? So we then made a decision. Usually people care about the one that has the most streams, the one that has the most Instagram followers. So we push that information that lives within Snowflake directly into MSK. We use a technology called KSQLDB to join that data with the changes that are happening from the knowledge graph. So Beyonce's 100 Instagram followers, 100,000 Twitter followers, streams, they all get joined and created into a new topic, which then gets pushed to OpenSearch. So your users have better search, faster, more intelligent, and there's no data lag. I'd consider that a success. Cool. The second thing we realized is by having MSK here as a message bus, we can have other applications leverage the fact that changes are happening within the system and action it. We can then start to really get closer to the user, closer to when they create that event. Instead of hooking onto the database, why don't we hook onto the service itself? So we know some changes happened to a piece of music and we can action it. So the use case we targeted here was the use case of when a manager is trying to plan a release of a new album, they have to constantly log into the system and check what the status is. Has the artist added another track? Have they changed the release date? Have they changed the artwork? And anything along those lines, right? They have to constantly go into the system to check. Secondarily, some artists will integrate with external services to create, let's say, a landing page. They have a landing page, they give it to their fans, and something changes, like the release date, right? How do you make sure that that stays up to date? In the previous system, we had cron jobs that would periodically query our API to see, has anything changed with this or not, right? But also remember, because of the nature of our teams, how we're all distributed and every single team has their own service, to answer a question as simple as has something changed in this album, we'll have a cascading effect that touches 5 to 10 different services. So you're needlessly wasting resources. So what we did here is we flipped it on its head. Instead of having the user poll, query, or refresh a page, why don't we tell them when something has changed? So we've tried to hook onto as many microservices as we can that take care of different things, right? Take care of the fact that a new account has been created, a new artist has come into existence, or something has changed on an album, and quickly send an email notification to that manager that cares about it. Now they don't have to be awake for 10 hours constantly refreshing a page. They get an email. We can connect directly to that external CRM if they have an API using another Kafka connector to make a HTTP call and let them know, hey, the date for this release has changed. Cool. The third and last use case we took MSK to is seeing what can we do internally. How can we make the life of our engineers and staff easier? How can we reduce toil? I'll go through a quick example for you guys. So being a music company, we have a lot of talent scouts. What they do is they go to festivals or gigs, get the contact details of up-and-coming artists that might have potential, keep them in spreadsheets, and just try and keep an eye on them if something happens. So their workflow is usually they'll create or edit a spreadsheet with all of the information of the new talent that they're looking out for. And when they want to see additional information next to that, like how many followers has this person gained, right? How much more streams do they have on SoundCloud or whatever it may be. They have to export that spreadsheet, upload it to a third-party system, and crunch the data so that they can see it on a dashboard. That sounds simple enough, but remember, we're a global company, so we have hundreds of talent teams. And then they can easily start to step on each other. If two people export different versions and upload it to the system, you could then have a clash. So we realized what we could do is we could put MSK in the middle. They all work in Google Sheets. There's a Google Sheet connector, like there's a connector for everything. So instead, we stream all the changes directly into the dashboard they care about. So all they need to do is just look at it. That saves them time and enables them to be able to action things quicker. Remember back what Vidi said? The quicker you can action some data, you've been put into a better position. All right, so I've gone through these 3 use cases. And showing this diagram again, I hope it now makes a bit more sense, right? We now have the ability to replicate in real time between data stores. We have the ability to action any kind of event that happens in real time. Cool. So what benefits have we achieved with this? Again, it goes back to velocity. It goes back to enabling teams to work at a faster pace and to innovate faster. We've gone from a week for teams to be able to accurately prototype any kind of new data product they have in mind to a day. Remember, it would take you 10 hours to synchronize from a database to another database. That's if you found the source for the actual data you wanted. Maybe you copied it from the wrong data store. It now takes from 10 hours to 30 minutes to synchronize 2 databases, and that's in the worst case scenario. And it's now gone from hours to minutes for someone to discover the data point they care about. What does that translate to? Higher customer satisfaction. Our products are more intuitive, they're more seamless, they're more reactive, and that brings about increase in the product. We have improved business agility, right? Our talent scouts can make decisions quicker. They have higher customer retention, and we now have insights that are more actionable. Increased developer efficiency. Our developers can now really focus on their business logic, really focus on delivering value to their customers, and not have to worry about, oh, how do I debug or log this issue that's come across while I'm trying to replicate information. Everything is centralized, and everything is now generic. Cool. The lessons that we've learned along the way are, 1, always make sure that you're laser-focused and well-scoped in terms of the first version that you want to deliver. It was really important to us to prove that we could deliver value to our customers, going back to the first search experience. And by doing that, that's allowed us to then look at the next step. What is the next most valuable thing we could do with that? Secondly, it was important for a platform-level framework to bring everyone across the organization together, because it has to work for every team. The accounting team needs to feel like they have as much to gain from this as the publishing team. And most importantly, it's important to make it easy to use. We try to make it as self-serve as possible, as hassle-free as possible, and you don't need to spend hours or months learning a new technology. It should be plug and play. All right, so I've told you a little bit about our journey so far, but going forward, now that we've proved that it does work, we want to scale it further. We want to grow across the organization and see what other use cases can we bring this to. After that is driving further cost optimizations. That's not to say that the platform isn't lean or that MSK is expensive, not at all. It just means that we know there's more opportunities that we could to drive cost optimizations, such as, for example, can we merge 2 clusters? Can we look at using MSK serverless for bursty traffic? And with that, I would like to bring back Vidi to close for us.
Thank you, Farooq, for sharing your story with us. It's so amazing to see what you've been able to achieve so far and what's next to come for you. Thank you.
Thank you.
All right. So as we close, I'd like to highlight some of the key capabilities of MSK. MSK provides a fully managed Kafka and Kafka Connect environment that is highly scalable, highly available, fault-tolerant and secure by design, and tightly integrated with multiple AWS services. It is simple for you to use. Within a few minutes, with a few clicks, you can create your entire Kafka environment leveraging MSK, and then you can scale with horizontal scaling by adding additional brokers or vertical scaling by changing the family type or the size of an instance family of the brokers. It is cost efficient. Many of our customers have told us that they are able to achieve over 60% of cost efficiencies by just moving over to MSK from their self-managed Kafka deployments or some of the other managed services out there. And when it comes to consumption, we are also providing you choice. So with MSK provision, you can have complete control of your environment, of your cluster. You can size the cluster. You can pick your custom configurations for the cluster. With MSK serverless, you get a hands-off experience. You don't have to worry about right-sizing your cluster. The environment automatically scales based on the changes in your needs. And then you get throughput-based pricing. So you're only paying for what you're using with MSK serverless. And then we have Kafka Connect that gives you a fully managed Kafka Connect environment with MSK Connect. And then you can use Glue Schema Registry for governance of your data streams. So that's all what we had to share. I'd like to thank you again for joining us here.